Hello students, welcome to today's session. So today we are going to discuss tokens. In the last session we discussed character sets. So from character sets you can form tokens, just like from alphabets of the English language you can form English words. Okay, similarly in Java also you have got certain words that are predefined. Okay, they have certain meaning, they are part of the Java language. Just like in English language you have you have apple, mango, house, sky. These words are predefined, they convey a certain meaning to the users and knowers of the English language. Similarly in Java also you have certain predefined words which convey some meaning to the Java compiler. Okay, so a few examples of those words are here. So you can see the list of tokens that are used in Java and they provide certain meaning to the Java compiler. So for example, boolean, byte, case, char, class, continue, default, do, double. So this whole list of words are used in the Java language, and each of these words convey a certain meaning to the compiler. Okay, now in our case we will be seeing more, we'll be using most of the words from this list, but there are certain words which we will not be using, like abstract, assert, go to, strict, fp, super, and a few more. Okay, so these words we will not be using, but majority of the words we will be using throughout our course. So these are also known as Java keywords. Okay, so keywords are just one part of the Java token library. Okay, so we'll see there are different categories of tokens, and these Java keywords is just one of those categories. So tokens are a combination of certain characters, or a token can also be a single character, and they convey some meaning in the Java language. Okay, I hope this point is clear. The next point is tokens are also the smallest individual units in a Java program. So what do we mean by this statement? To understand this, let's see a small program, and in that program we'll try to identify the individual tokens. Okay, so in this program you can see that I've written a few lines of code. Okay, but our purpose here is just to identify what are the different tokens used here. Okay, and we'll be focusing on keywords kind of tokens. So if we see public, class, static, int, boolean, char, private, all the words, and void also. So all these words are known as tokens. And which category of tokens? Keyword category of tokens. All these tokens are of the category keywords. Okay, all these underlined words are keywords, and each of them is a token. Okay, it's a word. You can relate it to the word part of the English language. Okay, so in the English language, see, in the English language, you have an English literature which is formed using sentences, and the sentences are formed using words, and the words are formed using alphabets. Similarly, a Java program is made up of Java statements. Java statements are made up of Java tokens, and the tokens themselves are made up of combination of characters from the character set. So in this case, these words here are individual tokens, and because they are valid tokens, if we click on compile, here, we do not get any error. Okay, as you can see here, class compiled, no syntax error, right? But let me just modify the program. So I'm giving a space here between pub and lic. Okay, so the public word has been splitted into two words, pub and lic. Okay, so you can see the space here. Now pub and lic, okay, both these words are not part of Java tokens or Java keywords. That is why when I click on compile here, you can see that it is showing errors. Okay, since pub and lic, these words are not recognized by Java. Okay, so these are not valid tokens. And when we do have a valid token, so this public and class, they are two different tokens, and when I give any number of space here, so you can see I have given a few spaces between class tokens and public. Okay, now if I compile, the program still runs, it still compiles successfully. Okay, so the space here does not cause any error. That is because we still have valid individual tokens. Okay, now not just spaces, if I want, I can add a few lines. Okay, so you can see after public there is 3 lines here, 3 blank lines, isn't it? But if I click on compile, the program will still compile without any error. Okay, so as long as you have valid tokens along with proper syntax, you will not get any error. Now, what is the meaning of proper syntax? Let's say instead of writing public class tokens, I wrote here class public tokens. You can see I have changed the order of public class. Earlier it was public class, now it is class public. Okay, so now if I click on compile, you can see that we have found errors, okay, and the program has not compiled. Okay, so this is what is meant by syntax. So for your program to compile properly, first of all, you should have correct tokens, and those tokens should be combined in a suitable manner using the syntax rules, using the grammar rules. Grammar is in English, but in Java it's known as syntax. Okay, so public class is not same as class public. Okay, so let us change it back to the way it was. I'll write here public class again, and now if I click on compile, you can see that we don't have any error here. Okay, so I hope you have got a glimpse of what is syntax, okay, and how tokens are combined using proper syntax. So smallest individual units, it means that these individual words or certain special symbols like brackets and semicolon, these are the smallest units. They make up the Java sentence. So these individual smallest units make up the Java statement. Okay, so that is why tokens are known as the smallest individual units. Okay, now let us see the different categories of tokens. Okay, we have different categories. Till now, whatever example I showed you in this program, okay, I showed you public, class, static, void, int, boolean, char, void. All these words are tokens, but they belong to the category of keywords. They are keywords. Okay, apart from these keywords, you have four more types of tokens. Okay, they are identifiers, literals, punctuators, and operators. Okay, so let's see each of them one by one. Okay, so coming to keywords. Okay, keywords, what are keywords? Keywords are reserved words, as I've already explained. Just like in the English language, you have already created words which convey certain meaning. Similarly, in Java also you have got already created words which convey certain meaning. Okay, and that is why they are known as reserved words, and they convey a certain meaning to the compiler. Okay, and they cannot be used as identifiers. I will explain this point later on, okay, because we haven't discussed identifiers yet. So I'll cover this point later. The keywords cannot be used as identifiers. The next point is all keywords are reserved words. So all keywords are reserved words, but all reserved words are not keywords. What is the difference here? So if we look at this list of keywords, okay, I have already shown you these keywords. So these keywords are known as reserved words. Okay, they are reserved words, and all of them are Java keywords. But there are a few words which are reserved words, but they are not keywords. Okay, they are reserved, but they are not keywords. What are those words? They are true, false, and null. Remember three words: true, false, and null. These three words are reserved words, but they are not keywords. Okay, see, true and false, they are used in logical expressions. I'll explain the meaning of logical expressions when we discuss operators. Okay, so true and false, they are the result of logical expressions. Okay, and null is used to initialize objects. Sorry, not initialize objects. I'll explain null later. Okay, because this is beyond the context of this chapter. Okay, so I'll cover null later. Okay, with the meaning of null I'll cover it later. But here you must remember this point, that these three words, true, false, and null, they are reserved words, but they are not keywords. And that is why I've written this point here: all keywords are reserved words, but all reserved words are not keywords. Right? So we are done with keywords. Now let's see what are identifiers. So identifiers are names given to different components of a program. And what are those components? Components like class, variables, methods, and not methods and functions. They are same thing. Okay, so whenever I use the word method, understand it to be the same as function, and vice versa. Okay, so class, variables, functions, and objects. Now remember, identifiers are used to give a name to a class, to a variable, to a function, and objects as well. Okay, these four components of our program requires us to give it a name. Okay, and that name is known as identifier. Now let me make this point more clear by explaining it in a program, in the same program which we saw earlier. So we have got a class here, right? We need four things. We need a class, we need a function. So in this case I've got three functions, right? Third is variables. So I've got three variables here: x, y, and t. And objects I'll explain later. Okay, first let us focus on these three components. Okay, we are focusing on class, variables, and methods. See, this tokens, tokens is not part of the Java keyword. Okay, it's not part of the list of Java keywords. So the list which we saw here, if you see this list, you'll not find tokens word anywhere. Similarly, you will not find this main anywhere in that list. You'll not find this show also, you'll not find this display also, and you'll definitely not find this X, Y and T. Okay, but still the program is compiling. This program is compiling successfully. Why? Because these are known as identifiers. These are known as identifiers kind of tokens. Remember, the first kind of tokens which we saw was keywords. Now we are looking at different kind of token which is known as identifier. And what are identifiers? Identifiers are used for giving a name to a class. So this is our class and we have given a name to it. Tokens. Tokens is the name of the class. Similarly, we have created a function here and the name of the function is main. So this main is the identifier which is identifying this particular function. This particular function is being identified by the name of main. Similarly, I've got another function here, okay, and that this function is being identified using the name show. Similarly, this function is being identified by using the name display. Okay, so display, show and main and tokens are identifiers. So I've covered class example and functions example. Okay, now I'll explain variables with respect to tokens, identifiers specifically. So as you can see, I've got a few variables here. I've written int x, boolean y and char t. These are known as variables. Okay, I'll explain variables and functions later on in detail when we cover these topics. Okay, but for now you must understand that these are variables and their name is, this x is a variable of type int, this y is also a variable of type boolean, and this t is also a variable of type char. Okay, so this is our third kind of identifier. Okay, so identifiers are used for naming a class, they are used for naming functions, and they are used for naming variables. Okay, so identifiers help us to identify class, functions, variables, and the last category was objects, which I have not shown you. Okay, so let me show it to you. Objects. For example, I compile this program and I'll execute it. So this is our class tokens, right? I'm going to compile here and I'll click on new tokens to create our object, right? Now see the name of the instance. name of instance, that is name of our object. Now whatever name I write here, that name is the name of the object. Here by default it's given as tokens 1. It's given as tokens 1. Okay. So if I click on OK, an object is created here, and the name of this object is tokens 1. Okay, so this tokens 1 is an identifier which is identifying the object of kind token, and its name is tokens 1. Okay, so remember, identifiers are used for naming a class or variables or methods or objects. So this was our second kind of tokens. We have so far covered keywords, identifiers. Now let us look at literals. What are literals? Okay, and before we move to literals, there are certain rules while we use identifiers. Let us go through these rules. Okay, rule number 1. Identifiers can consist of any combination of letters, digits, underscore sign, or the dollar sign. Okay, you must be very clear with this point. You can use any combination of letters, digits, underscore and dollar. You cannot use any other special symbol, only underscore and dollar. For example, you cannot use full stop, you cannot use comma, you cannot use semicolon, you cannot use greater than sign, you cannot use less than sign. Only two symbols are permitted in identifiers, and they are underscore and the dollar symbol. Okay, so this is rule number 1. Identifiers can consist of any combination of letters, digits and dollars. So let me show you in a program. So let's erase all of this, or let me create a new program. Okay, identifiers. So our class is identifiers. Okay, this is our first identifier. Okay, and its name is identifiers, right? Now let me show you. If I compile this program, you can see class compiled, no syntax error. But if I okay, let us use an underscore symbol here. Okay, and then dollar. Okay, I compile this, you can see that it has compiled successfully. Again, we don't have any error. Okay, no syntax error found. You can place this underscore and dollar anywhere. You can place it here also, you can place it anywhere in between the characters. Okay, compile it, we still are good. We don't have any compile error, right? Now let me use some other symbol. Instead of dollar and underscore, let me use, let's say, ampersand. Okay, and let me compile it again. So you can see errors found. Okay, as soon as I wrote ampersand here, identifiers ampersand, what happened? We received an error. Okay, so as I told you, only underscore and dollar signs, these two symbols are allowed to be used in an identifier. Okay, so this was class name, right? Where else can we use identifiers? Yes, in variables. So let us make a variable. And before variables, where else can we use identifiers? Identifiers should be used in functions also, isn't it? So if I write here, let's say void main. So this main is a function, right? This void main is a function. The name of the function is main. Okay, so main is also an identifier. Now let me remove this ampersand from here. So this function, in the function name also the same rule will apply. Okay, the same rule. Let me use here underscore sign and let me put a dollar sign here. So am dollar $AIN underscore. If I compile this, I will not get any error as expected. Class compiled, no syntax error, right? But if I use some other symbol, let's give a percentage sign here. Am dollar $A percent IN. So this percent will cause an error. Okay. So as you can see, we have already received an error message here, that error is there, and a red line is also showing here, a curved red line. I don't know if you can see or not, but a red curved line is showing here, and the error is also being shown, invalid method declaration, return type required. This error is coming due to this percentage symbol. If I remove the percentage symbol from here, everything will be fine again. See, compile, and we have no syntax errors, right? So I've shown you the example for class. Okay, functions I've shown you. Now let me show you the example of identifier in case of variables. So let's make a variable of type int. Okay, so int x is equal to 10, or let's change the name of this variable as num. So this variable name is also an identifier. Okay, but this identifier is being used to identify a variable. Okay, it's not being used to identify a class or a function, but it is being used to identify a variable, okay, of type int. So in this case also the same rule will apply. I can use the dollar symbol and I can use the underscore symbol. The program will compile, no syntax error. But as soon as I put some other symbol here, like hash. Again, same output, error found. Okay, so notice here errors found in class. Okay, and finally I'll show you the example. By creating an object, because identifiers are used at four places, isn't it? To identify a class, or to identify a function or a variable, or the third or the fourth kind is objects. Okay, so let me create an object and I'll put a percentage sign here, identify 1%, and I click on OK. What happened? What is the error you are getting here? The instance name must be a Java identifier. You see, this object name also cannot contain any symbol apart from dollar and underscore. So let me put a underscore sign here and let me click on OK. You can see that the object has been created here. Okay, and the underscore is there. So I hope this second kind of token, which is known as identifier, is clear. So let's see the next point. So this was our first rule for naming identifiers. The second rule for naming identifiers is you cannot begin an identifier with a digit or any special symbol. Okay, actually you cannot use the special symbols anywhere apart from this underscore and dollar, but underscore and dollar can be at the beginning also. Okay, so this point should not have been mentioned. Okay, you can cross out this point. Let's focus on this. It cannot begin with a digit. Okay, so let me write here the name of the identifier as num. So if I click on compile, it will compile. Okay, no syntax error. But what will happen if I put num1? Will it compile? Yes, it will compile, because our rule says that you cannot start an identifier with a number. That is, I cannot put a number here right at the start of the identifier. Okay, if I do this, what will be the result? The result is this: errors found in class. Okay, but I can place digits anywhere in between the characters, okay, or at the end of the last character. This is not a problem. This will compile. So compile, you can see class compiled, no syntax error. Okay, so this is our rule number 2. You cannot place a number at the start of an identifier. Okay, let me put here also 7 identifiers. Will this compile? Will it? No, it will not. Okay, so compile, and you can see that it is showing error. Okay, and a red line also has appeared here. Okay, but you can definitely place somewhere in the middle or at the end. Okay, so this will compile, or will it not compile? It will compile. Okay, okay, I've changed the name of the class, so this is causing a problem, but this is not an error, students. This is not an error. Okay, so just hold on, let me close this, because since I've changed the class name while the program is while we are editing the program, that is why this problem is being caused. Okay, So don't think of it as an error. Okay, I'll clarify this point. Just let me get through this. Okay, students. So I was changing the name of the class and I was trying to write some numbers, right? So let me just show you here that we can use numbers. Okay, let me give the class name, the identifier name as ABC67GH54. So this is perfectly okay, and the class has been created. It is right in front of you. Okay. And if you compile this, you can see that the class has compiled with no syntax error. Okay, the class has compiled successfully. But if I create a new class again and let me start the name with a number, it will not happen. See, not a valid Java class name, right? So I hope this point is clear. The second point, that identifiers cannot begin with numbers. Okay, but numbers can very well be used anywhere in between the identifiers or at the end of the identifier. Okay. The third point is that it can be of any length. Okay, you can make an identifier as long as you want. Okay, the length is not a problem. Second is the fourth is, both it can be both uppercase letters as well as lowercase letters. Okay, so this is the fourth rule. The fifth rule is that since Java is it's a case sensitive language. What is case sensitive? Case sensitive means capital A and small a, they are not the same. This is the meaning of case sensitive. Okay, so let me show you a practical example for this. So I've created a variable here num1. Okay, if I compile this, it will compile successfully, no error. Okay, let me make one more variable int num1. Again I've given the same name. Okay, will it compile now? It will not compile because every identifier should be unique. Every identifier should be unique, and num1 is already used here. So I cannot declare another variable with the same name. Okay, but if I make this as capital N or any of the letters, I change the case. Okay, what will happen? Will this compile? Are the identifiers same or different? The answer is it will compile and the identifiers are different. Identifiers are different, and this time we don't have any syntax error. See, num1. This num1 is different from this num1. And why is it different? Because we have got a capital N here. Okay. Similarly, if I make a third variable, okay, and this time I make the u capital and num1 is equal to, let's say, 30, right? So again, if I compile, will it compile? Yes, it will compile. Okay, no syntax error. So this was our fifth point. Okay, that identifiers are case sensitive, and for that matter, everything in Java is case sensitive. Everything in Java is case sensitive. Listen to this statement. Okay, that means what? Public class, they are keywords, right? That means if I make this capital C here, it will cause an error. Why will it cause an error? See, error has come up. Why is this causing an error? Because Java is case sensitive, and in our list of words given in the Java keywords table, you can see this class here. There is a small c. Okay, so small c cannot be used, cannot be replaced by a capital C. They are not the same. That is the meaning of case sensitive, and that is why this capital C is causing a problem. It's causing an error. Okay, so we must be very careful with the case of the letters. Okay, and many students make this mistake while they are in the lab. They will write some Java keyword, like let's say this only, like class or public, but there sometimes their L is capital, sometimes P is capital. Okay, so all these simple points must be clear. Okay, that Java is case sensitive, and every word that you use in the program should be a valid token, taking the case of the letters into consideration as well. Okay, so we are done with identifiers. So we have covered keyword type of token, identifier type of token, and we are left with literals, punctuators, and operators. Okay, so the remaining tokens I'll be covering it in the next session, and we will stop here for now. Thank you.